Okay, today we are going to be working on video notes 10. This section is part 1, which is over adding and subtracting inequalities. So we're first going to start off by talking about a property which says that equivalent inequalities are inequalities with the same solutions. For example, x is greater than 10 and x plus 2 is greater than 12 are equivalent inequalities. And they're equivalent because you can add the same value to each side of an inequality just as you did with equations. Because as you'll see when we start solving, remember when we did equations, you would subtract 2 from this side, and that means you would also subtract 2 from this side. So when you subtract 2 from this right side, you end up with 10. So you still have x is greater than 10. So that's why they are equivalent inequalities. Okay, I'll give you a couple more seconds to go ahead and get that filled in. And if you hadn't noticed, you should be on page 40 of your video notes because all the other pages said in class Monday. And right here is where you saw video notes part 1. So this is where we're starting. So as you see, you don't actually have a lot to do for homework this weekend like you thought you did. Go on and smile. Okay. So our addition property of inequality says that for every real number, a, b, and c, if a is greater than b, then a plus c would be greater than b plus c. Because the only thing that you notice that's changing is the a and the b. So it's basically saying if I add the same thing to both sides of my inequality, it's going to stay balanced, just like our equations. Because remember, we're going to add the same thing to both sides. Okay, and the same thing works for less than. So if a plus c is less than b plus c, then, or if a is less than b, then a plus c would be less than b plus c. So I gave you some examples. So if I have 5 is greater than 2, in this case, 5 is a, 2 is b. So my c value that I'm going to add is here in my then statement. So notice on both sides, I'm adding 3. So the reason why it's true, because if you were to solve this, you would end up with 5 plus 3 being 8. 2 plus 3 is 5. Is not 8 greater than 5? Yes, so that checks to be true. Okay, when we come over here to the less than symbol, okay, my A is 4 this time. My B is 10. So I'm going to add the same C, which is 3. So let's check to see if it's true. Since I'm adding the same value to both sides, 4 plus 3 is going to give me 7. 10 plus 3 is going to give me 13. So wouldn't I put a less than symbol in between those two numbers? So therefore, that says that your property of inequality for addition is true. And this says that it also is true for greater than equal to and less than equal to. So it doesn't matter which of the 4 symbols that you put in there, the property should be true because you're going to do the same thing on both sides, just like you would do with solving equations. Okay, if you haven't finished copying that, you can pause the video, but I'm turning to the next page. Okay, so now you should be on page 41. Okay, and at the top here, I want you to go ahead and write that we're going to solve just like you do equations. Can't stress that enough. Okay, so you're not really doing anything new. The only thing that's different is you have inequality symbols instead of an equal sign. Okay, so it says solve, then graph the solution set. So if I have x minus 3 is less than 5, we're still going to use inverse operations, just like we did with equations. So since we have subtraction right here, then that means you would do its inverse, which is addition. So therefore, we're going to add 3 to both sides of the inequality. So the 3's cancel, and that leaves you with x is less than 8. So what we did in step 1 was add 3 to both sides. Okay, and remember you did graphing in video notes 9. So to graph, remember we look at the number, and that is going to be our starting point. So on your graph, you usually want to put your starting point in the middle somewhere, and then fill in values on either side. So we know to the right will be 9, 10, 11, to the left 7, 6, 5. Put your circle at 8. Since our variables on the left is pointing to the left, so therefore it should be less than. So draw your arrow to the left. Now determine, do you need to fill in your circle or not? So remember, if you have just less than or greater than, your circle is empty. If you have less than or equal to or greater than or equal to, your circle gets filled. So therefore, we should leave this one empty. There's your graph. Okay, let's check. Now, when we check, since it says x is less than 8, then that means your answer would have to be something like 7, 6, 5, 4, 3, 2, and so on and so on. So you can pick any value that is less than 8 and plug it in to check. So we're going to use a value, less than 8, since x has to be less than 8. So in this case, let's just try 6. So if I plug in 6 to my inequality, let's go ahead and write it down again. If I plug in a value of 6, I would have 6 minus 3 less than 5. Since 6 minus 3 is 3, I see that 3 is less than 5. So since this is true, it checks, because we're always looking to make our inequality true. Okay, now you have some understanding check problems. So you're going to pause the video and work on those, and then continue. Now, don't forget what we talked about in class. Remember, you want your variable to be on the left side. And also remember, if you have a negative variable, that everything needs to change to the opposite. So that means your variable changes to positive, your inequality symbol flips or reverses, and your number that's on the other side, you're going to write its opposite. Okay, the same thing for one like this. If your variable is on the left side, remember, we want this variable to be on the right side in the end. So therefore, if I take my variable across the inequality, which is like going across the bridge, we're going to the opposite side. So therefore, we need to do the opposite of our inequality symbol. So do those problems and we'll check in class. Okay, now you should have finished your understanding check. Let's go on to subtraction property of inequality. Okay, so it says that for every real number a, b, and c, if a is greater than b, then a minus c should be greater than b minus c. Also, if a is less than b, then a minus c should be less than b minus c. So let's do an example and plug in some values and check to see if that is true. Okay, in this case, my 10 is my a, my 6 is going to be b. So let's find us a c value, and I'm using 2 in this case. So if I plug in 2, since I need a minus c, I'm going to do 10 minus 2. And on the other side, I'm going to do 6 minus 2. So if I were to solve that, I know that 10 minus 2 is 8. 6 minus 2 is 4. 8 is greater than 4. So that does prove to be true. It would check. Okay, same thing for our less than symbol. In this case, I've given A a value of 4. I've given B a value of 11. And I'm going to bring over that same C value of 2 this time. So A minus C would be 4 minus 2. That's 2. Our B minus C is 11 minus 2, which is 9. 2 is less than 9. So that checks to be true. So it's the same if we were doing subtraction. Because remember, it's just like solving an equation. If you have a subtraction problem, you're basically going to add the same thing to both sides, so it's going to stay balanced. Okay, so let's do an example together. Okay, so using my subtraction property, this means I'm going to end up subtracting from both sides. So since I have y plus 5 is less than negative 7, since 5 is with my variable that I want to isolate, then that means I need to do its inverse, which is subtract. So we're going to subtract 5 from both sides. So my 5's are going to cancel, leaving me with y is less than negative 12. Because remember, use your integer rules. This is like saying negative 7 plus negative 5. It's negative 12. So what I did in my step was I subtracted 5 from both sides. So we're going to write subtract 5 from both sides. Okay, to graph, remember we want to put our number in our inequality in the middle. So we would have negative 12 in the middle and then fill in your values around it. Now since I know these are kind of close together, you can skip. So since you know right here would have to be negative 11, then we can skip that and just write negative 10 here, because you know that would be negative 9 and so on. So as I go this way, this will be negative 13. We're going to skip that and just put negative 14 right here. That way our numbers aren't all bunched in together. Okay, let's graph. Since we know we started at negative 12, put your circle. Since it says it's less than negative 12, we need an arrow going to the left. And since our inequality symbol does not have an equal to part, we're going to leave it open. So there's your graph for y is less than negative 12. Okay, let's check. So since x is less than, or y is less than negative 12, then that means we need to use a value that is less than negative 12. Now don't get confused because we have a negative. Remember, negatives are opposite of positives. So think about it as like, you're going down in a hole. The deeper you go, the more negative you are. So the smaller you're getting. So actually, as you go to negative 13, negative 14, negative 15, you're actually getting smaller than negative 12. So let's pick a value that's less than negative 12. So that means it has to be like negative 13, negative 14, negative 15. So let's try negative 15. So since we started with y is less than negative 12, let's plug in our negative 15 into our inequality, which was y plus 5 is less than negative 7. So plug in negative 15 plus 5 less than negative 7. Negative 15 plus 5 is negative 10. Is negative 10 less than negative 7? I hope you didn't say no, because that is true. Remember, I just got through telling you, the larger you go into your negative numbers, the smaller you're actually getting. So that's true. That actually checks. Okay, just finished page 41. Next, on page 42, you see you have your understanding check, which is your part. So you're going to solve these 4 inequalities for your practice, and we'll check them in class. So pause the video right now and go ahead and do those 4 problems. Okay, the last part of our video notes 1, or part 1 of video notes 10, is we're going to do a word problem. So anytime you see application in math, that has to do with a word problem. Okay, now remember, we always want to cube when we're doing our word problems. So we are circling our numbers, we are boxing important words, and you're putting whatever sign or symbol that goes along with that keyword right there with it. So by the time you finish, you should pretty much already have your problem written out. Okay, it says the maximum safe load of a chairlift is 500 pounds. I see 500 pounds. I see the word maximum. And you should remember that from your video notes 9, I had you add the word maximum, because maximum means it cannot go over that amount. So it can be equal to or it can be less than that amount. So therefore, maximum is less than or equal to. So we're already seeing that basically it should be less than or equal to 500 in our inequality. Okay, now it says the cyclist rides the chairlift with his bicycle. The cyclist weighs 160 pounds and the bicycle weighs 30 pounds. So what that means is basically the cyclist is going into the chairlift on his bike or with his bike. So therefore both of those are going into the chairlift. So that's going to be added together. Now the question asks, which inequality best describes how much additional weight, W, the chairlift could carry or could safely carry? So basically we're trying to find out what is it that I can add to my 160 and my 30 but not go over 500 pounds. I mean, I can touch 500 but I cannot go over it. So therefore, since I know I need to do my cyclist plus my bicycle plus whatever additional weight all that together is not to exceed your 500 pounds. So therefore, since the cyclist is 160 pounds, the bicycle is 30 pounds, the additional weight they already told you to use W cannot exceed 500 pounds. Now remember, when we solve our equations, excuse me, we have to combine like terms. So in this case, hold on, get to put my new pen beside me. Our like terms are the numbers by themselves that have no variables attached. So we see our like terms are here and here, because we have like terms on the same side. I forgot to include that plus in there. So the first thing we need to do is go ahead and combine 160 plus 30 to get 190. And let's rewrite the list. So now since I see that I have 190 plus W and I'm trying to isolate my variable, then that means I need to remove my 190. So the inverse of this 190 is subtraction. So I would subtract 190 from both sides. The 190s cancel. So that means the additional weight has to be less than or equal to 310 pounds. So that means I can be 310, 309, 308, 307, or whatever. I just cannot be 311, 312, or else I've exceeded the maximum limit. Okay, you have one final understanding check, so you're going to try you an application problem. Make sure that you cube. Make sure that you write out your inequality as you're going along. And we will check that on Monday when you come in. Please make sure that you write down any questions and post on the parking lot. Most of you have forgotten to do that. Okay, I will address all of your questions that are on the parking lot as soon as you come in, and we get our day started after your warm up. All right, boys and girls, I've enjoyed you. Have a good weekend.